Think about it for a second. It's a perfect summer day. The water feels amazing. You jump in, splash around, and maybe, you get a little water up your nose. Happens all the time, right? No big deal. But what if this one time something came back with that water? Something microscopic with a plan.
So that's what we're diving into today. We're going to break down one of the most terrifying biological heists in nature. We are talking about a single-celled organism that has perfected a way to get inside the most secure vault in the human body, the brain.
You know, every great heist needs a mastermind, and this one is a true monster, but it's hiding in plain sight. It's not some creature from a movie, it's a real organism, just lurking in the warm, fresh waters that we all love to swim in.
All right, so let's meet our microscopic cat burglar, Naegleria Fowleri. Now that word thermophilic is super important. It basically just means heat-loving. This thing thrives in warm water. Think lakes and rivers in the summer months, even poorly kept pools. And trust me, it has absolutely earned that terrifying nickname. And here's the thing. Our mastermind is a shapeshifter. It has 3 different faces. The cyst is its survival mode, for lying low when things aren't ideal. The flagellate form is all about movement, a quick getaway car to find a better spot. But the trophozoite, that's the one. That's the real villain of our story. This is the form that actually carries out the heist.
So how does this whole terrifying heist even begin? Well, it all comes down to one critical moment, a single point of entry that turns a fun day at the lake into a point of no return.
That's it. That's the whole trick. You don't get it from swallowing the water. The only way in is through the nose. So we're talking about swimming, diving, water skiing, even using something like a neti pot with contaminated tap water. It's such a simple, almost random event, but for the amoeba, it's the start of a very deliberate, very deadly journey.
Okay, so once it's inside, the amoeba doesn't just wander around hoping for the best. No, it has a map. It has a direct route, a superhighway that leads it straight to its target.
Here's the play-by-play of the invasion. First, the trophozoite gets way up into the nasal cavity and latches onto the tissue that's responsible for your sense of smell. Then, and this is crazy, it releases a cocktail of enzymes that literally melts the tissue in its path. And finally, and this is the key to the whole heist, it starts traveling along the olfactory nerve itself, using it like a secret tunnel straight into the brain.
This is basically its blueprint for invasion. It is an incredibly elegant and absolutely terrifying plan. It's a stealth mission that uses a backdoor connecting the outside world directly to the central nervous system, a path with pretty much zero security.
And this is the truly genius part of the heist. The amoeba completely bypasses the blood-brain barrier. I mean, think of that barrier as the ultimate fortress wall, designed to keep anything dangerous out of the super delicate brain. But by using the olfactory nerve, this little amoeba doesn't have to pick a lock or scale the wall. It just strolls right through a secret passage, completely avoiding all the guards.
So, what happens when the heist is a success? Once the intruder is inside the vault, the aftermath is unbelievably swift and just catastrophic. The body's response leads to a condition called primary amoebic meningoencephalitis, or PAM.
This number, it just speaks for itself. The case fatality rate for PAM is over 97%. I mean, out of hundreds of cases documented all over the world, you can count the number of survivors on your fingers. It is almost always a death sentence.
And the speed is what's so horrifying. It starts with symptoms that could be anything. A headache, a fever, maybe you feel sick. But within just a few days, it escalates to serious neurological problems, a stiff neck, confusion, seizures. And by the end of the week, it's usually coma and then death.
That term brain eating is catchy, but the reality is somehow even worse. It doesn't really eat the tissue, it releases those same enzymes it used to get in, but now it's doing it inside the brain. And this causes massive inflammation and just dissolves the brain tissue. It turns it into a liquid. It's not just robbing the vault, it's completely demolishing it.
So, is there any way to fight back against a predator that pulls off a nearly perfect crime? Well, there is, but it all comes down to one thing: speed. It is an absolute race against a clock that is ticking down way, way too fast.
The first huge problem is that our mastermind is also a master of disguise. When doctors do a spinal tap, the fluid they pull out looks almost identical to what they'd see in bacterial meningitis. It's cloudy, it's full of immune cells, the glucose is low. And this mimicry is deadly because doctors often start treating for the wrong thing and they waste precious, precious hours.
But
There are these incredibly rare stories of survival, and they all have one thing in common. Take the case of a 12-year-old girl. Her lab techs were looking at her spinal fluid, and they spotted something moving around that definitely wasn't bacteria. They identified the amoeba and got the word to her doctors in just 75 minutes. That speed, right there, changed everything.
Because they knew what they were fighting so quickly, the doctors could throw everything they had at it. A whole cocktail of drugs, including an experimental one flown in from the CDC. They put her in a medically induced coma and used cooling therapy to try and reduce the massive swelling in her brain. It was a total all-out assault, and it was only possible because they knew exactly who the enemy was.
And that kind of brings us to the final, really unsettling thought here. Naegleria Fowleri is a heat-loving organism, remember? So as our planet gets warmer, its habitat, those warm lakes and rivers, is expanding. We're seeing fatal cases now in places that never used to have them, like Minnesota. So the question we have to ask ourselves is, in a warming world, how long is this terrifyingly perfect predator going to stay a rare threat?